Hi everybody, we're going to go over radicals today. So the lesson was simplify. You have four things you can do with radicals: simplifying radicals, adding radicals, multiplying radicals, and you can never leave a radical in the denominator, so we rationalize denominators. So those are the four things we're going to go over. We're going to kind of incorporate two of them today. So radicals, 5, 6 in your book, radicals. So perfect square. These are the two types. We have perfect squares and we have these. Perfect squares are not considered, we're not going to consider those radicals, we're going to consider these radicals. If it's a perfect square, we're just going to turn it into a whole number. So perfect, it's a radical basically, and that doesn't come out perfectly. Simplest radical form. When I say I want something in simplest radical form, let's use variables to describe this. So when I say simplest radical form, I'm referring to, talking about variables, we have something we can break down. And I've seen all these tree methods. I broke it down in all these ways too. But I'm going to bring it all the way back. So w to the 8th. W to the 8th is really w to the 4th when it's written in simplest radical form. And here's how we do it. How? We take there's an imaginary 2 on the outside of every radical that we never write down, but it's there. And what you're really doing to get rid of the radical is you take that 2 and the 8 as the exponent here, and we make a fraction, 8 over 2. And that means w equals a 4th. And that's how we get the answer. And if it goes in evenly, there's nothing left over, and there's nothing in the radical. The radical vanishes. Perfect square again. So, example 1. X to the 10th. 10 divided by 2 is even, so we can just take out x to the 5th. Now we have a doubler. This 2, same rules. Square root of a to the 12th, b to the 30th becomes a to the 6th, b to the 15th. Let's see what happens when we get one that's not even. You got to separate it. You got to make it into something that is even. So a to the 6th is even, 1 left over. So that's going to give you, you separate it out, and you end up with a to the 3rd radical x. So that's an example. So these are the four things we're going over. We're going to do a little bit of multiplying, but number one is simplifying radicals. We're going to add and subtract radicals. We're going to multiply radicals, and we never leave a radical in the denominator. So we did another one. The radical is w to the 9th becomes w to the 4th, radical w. New one. So when you do numbers you got to make, you can do two, there are two options to doing this. Option number one is a tree, and anytime in that tree you get a perfect square root, stop and take it out. You get 5 radical 2, 50. Square root of 50 is 5 radical 2. Then there's called a prime factorization tree, where you just keep going until you have all the factors. Same idea though, when you get doubles, you take them out, and doubles go on the outside, singles go back on the inside. Same answer, same thing, same everything. So let's do square root of 8. Square root of 8 becomes 2 square root of 2, or square root of 4 times square root of 2. 2 radical 2 is the answer. Square root of 18 becomes 9, 2, or 3 square root of 2. Now we have one with both. Break down the 128. 8 to the 6 becomes 8 to the 3rd, and you write it like this. You put the a on the outside with the 8. That is now perfect. So keep it going. Now we're going to do a bigger one. If you get one like this, 4 and 3 go together, make 12. 10 and 6 go together, make 60. And then that's how you do it. You end up with, I use 4 instead of 3 and 30, but you can use 2 and 30. You can use 2 and 30, or you can use 4 and 15. You need to start learning to use those perfect square roots to divide into radicals that are not perfect squares. And when you do that, if you use 4 and 15, it gets the answer a little quicker than 2 and 30. And the answer is 24 radical 50.